I love this one. Find Waldo. Where's Waldo? Waldo finds himself. Hilarious. I crack myself up. Hey guys, what we're going to do in this video is just do a little quiz warm up. Make sure that you are ready for your quiz today. So we're covering the main questions from lesson 1, as well as a few from lesson 2. But remember that your quizzes really are open book. So as long as you've been doing the assignments, checking your work, and asking for help when you need it, you shouldn't really be having any problems on the quizzes. I do want to remind you of a couple things, though, things that I see people are making mistakes on when they're doing these Google form quizzes. When you are doing a short answer question, so let's say the question is, find how many ways can the 5 people line up? Your answer is just a number. It's like numerical response. You don't put any words in there. You don't put any letters. You don't put any other symbols. So just as an example, on our unit wrap-up, some people were putting in percentage signs. So the question was, what percent of the people, I can't remember, go cross-country skiing? And maybe the right answer was 20. You just put in a 20. You don't put the percent sign in, because then it won't match with the right answer. So short answer questions are just numbers. If it's going to be something else, I will let you know right in the question. And the other thing is to make sure that you read very carefully. I say it at the top of every quiz, but lots of people are making reading mistakes. I think that maybe there's some skim reading going on. Read the question twice. I put as much information as I think you might need. You know, in class, if you needed some clarification, you could always ask me. And I know that when you're doing these quizzes on your own, I'm not there to ask. So I really do try to make sure all the information is there, that it's very clear, but you have to read carefully. All right, into our warm-up. Ted has a 3-letter combination lock. He has to choose his own combination. He can use the letters given. How many different combinations are possible if he is not allowed to repeat letters? All right, so I think this is a good one for us to just practice our fundamental counting principle. I think at this point in the game, that's the one we're probably most comfortable with. So he would have to make 3 decisions. So let's get 3 blanks set up. All right, so Ted is going to make his first decision. What letter should go first? Now, I've counted the letters ahead of time, and there are 13 available or possible letters that he can pick from. Now, remember, it says here he is not allowed to repeat letters. So maybe on his first pick, he used T for Ted. T cannot be used anymore, so now there are 12 letters available. Maybe he chose E. E cannot be used anymore. There's now 11 letters possible. And so he multiplies and sees that he has a total of 1,716 different combinations that are possible. So as we go through our warm-up, a really good way to do the warm-up would be to hit pause, try the question, and then check and see how you did. So feel free to do that on any one of these questions. You are capable of trying it yourself. There's nothing new on this one. So number 2, how many odd 6-digit numbers can be made if repetition of digits is not allowed? Okay, so let's read again. How many odd? That's a restriction right there. That tells us the last digit must be odd. And we're also only doing 6-digit numbers. So a question like this where we've got restrictions in certain places, the best way to do this one is, again, fundamental counting principle. So let's make 6 blanks. If we were going to write a 6-digit number, we actually have 6 decisions to make. We have to decide on each digit. Sorry, this little pen is kind of funny. My multiplication signs look a little bit like X's, but those are all multiplication signs. Now, it doesn't come right out and talk about all of the restrictions in this question. It does say that we can't repeat digits, but there's other restrictions as well. Our last digit has to be odd. Our first digit can't be 0. So there's really 3 restrictions that we have to watch for in this question. Now we'll start with these spots that have specific restrictions. So let's look at our last digit. It has to be odd. So it could be 1, 3, 5, 7, or 9. Those are the only numbers that could go here. So there are 5 numbers available. Now remember, this 5 doesn't mean that 5 is the last digit. It means that there are 5 numbers that could go in here. Okay, let's go back up to the front now. When I go to do this, decide on this number, it can't be 0. So actually, let's just write out our numbers here. It is helpful sometimes to just have this little list so that you physically have something that you can see that's going on here. So when I go to pick this first digit, it automatically can't be 0. And it can't be, we can't repeat numbers, so it can't be the same as my last digit. So let's pretend that I chose 3 to be my last digit. When I go to pick this first number, there's all of these other 8 numbers that are possible. So there's 8 digits possible for this spot. Now, spot number 2 can be a little bit tricky as well. If we take a look at what is possible in this spot, well, it can't be the same as our last digit. So remember we said, okay, on our last digit, we pick 3. 3 is not available. Now, whatever we chose on our first digit, it's not available either. So there's 2 numbers now that are not available and cannot be used, but it is okay to use 0. So that means that there would be 8 digits available. And just think about where you are in this, setting up this number right now. You've already selected 3 digits. So that would mean there's 7 available for this spot, 6 for this one, and 5 for this one. And our answer here comes to 67,200. Okay, number 3. How many ways are there of getting from point A to point C if backtracking is not allowed? Now, you guys, this whole backtracking not allowed is always the case. Otherwise, we'd have no idea. There'd be no limited number. Because imagine if we could backtrack. Well, you could have some people going, well, I'm just going to go this way and I'm going to come back, and then I'm going to go a little farther and come back, and then I'm going to go back to D. I could go back to A because I forgot my lunch. I'm going to B, back to C. Like if you could backtrack, there would be an unlimited number of paths. Well, probably not unlimited, but it could go on and on. So there is never backtracking allowed in these questions. All right, so let's think about our decisions that we would have to make. If I'm going to travel from A to C, I could do it this way through point B, or I could go on this half through point D. So there is this hidden or question in here. So it means we have two different scenarios. One way would be going through B, or we could go through D. Okay, so let's just focus on going through B. Going from A to C, passing through B, I really have two decisions to make. My first decision would be, how am I going to get to point B? How am I going to go from point A to point D? And there are two ways to do that. My second decision, an easy one, how am I going to get from B to C? There's only one to choose from. So there's two ways to get from A to C if we go through that top half of the diagram. Now let's look at going through the bottom half, going through point D. Two decisions to be made again. First one is, how am I going to get from A to D? So there's three ways to do that. And then how am I going to get from D to C? Two ways to do that. Now, we've talked about how or, that connecting word, means add, but really adding makes sense anyway because we're trying to find the total number of ways. So we're going to add up those two numbers. And we're going to say there are 8 possible ways to get from point A to point C. And for number 4, how many numbers are possible using some or all of the given digits if digits cannot be repeated? Okay, and we're only allowed to use the 5 numbers that we are given. This is one of those questions where it just feels like information is missing. Use some or all. Very ambiguous. Like, well, what are they exactly talking about here? So this is where we need to use and include all possible scenarios, because it doesn't come out and say use 4 digits or you use 3 digits. It just says some or all. So we want to do all possible scenarios. So the first scenario I'm going to look at is we could use all of the numbers. Or maybe it's just 4 digits. Or, let's see, I'm writing too big here. Or maybe 3 digits. Or 2 digits. Or 1 digit. So we want to write down every possible scenario. Pardon me. So let's take a look at the first scenario. What if we used all of the numbers? Now remember that digits cannot be repeated. So I go to pick my first digit. There's 5 available. Then 4, 3, 2, 1. Okay, now if I'm only using 4 digits, it starts the same way. My first digit, there's 5 numbers available. Then 4, 3, and 2. If I'm using 3 digits, it'd be 5, 4, 3. 2 digits would be 5 times 4, and 1 digit would be 5. So a little bit of calculator work here. I find that this first one is 120. Or means add. This one also 120. Add again. This one would be 60, 20, and 5. So here we've got a grand total of 325 numbers are possible. So remember, something ambiguous where you feel like there's something missing, they didn't give you enough details, it means that there's going to be more than one scenario and you must include them all. Now, I threw number 5 in here because I want to do a little review here. This question, we actually have learned 3 different ways to solve this one. So when you are trying this one, when you hit pause, I want to see, can you think of all 3 ways to do this question? We want to figure out how many ways can 6 people line up at the water fountain. All right. My first method I'm going to use is the first way we learned it, and that's with the fundamental counting principle. This is where we set up our blanks. So if we're lining up, there's 6 people and I want to line them up at the fountain, I've got 6 decisions to make. I go to pick the first person I'm going to put in line, and there are 6 people available. Now I've selected one person and put them in line. So when I go to pick my second person, there's only 5 people available, and so on and so forth. I multiply that out, and let's see. Six times 5 times 4 times 3 times 2 times 1. I get 720. All right, the second way I'm going to do this is with factorial notation. As I was typing this in my calculator, that's kind of the point where I realized, hey, there's a shorter way to do this. If I'm multiplying by starting at 6 and using every number all the way down to 1, the quickest way to do that is just to say 6 factorial. Okay, so let's review how we put that into our calculator. So I start off with the 6. I go into math, over to probability, and it is the 4th one in the list. So 6 factorial, again, same answer, 720. And then we could also use our NPR notation, where N is the number of items available, R is the number of items that we'll be using in our arrangement. So in a case like this, we've got 6 numbers available. We are going to be using all 6 in our arrangements. When we use this notation, it automatically means that you are not repeating people in the lineup. Now it equals, again, 720. Let me just remind you of how to put that one into your calculator. And so I start off with the 6. I go to math, over to probability. It is number 2 in the list. And then I type in my other 6. I arrow out of it, hit enter, and there's my 720. So 3 different ways that you can do that question. Now, when you're doing your quiz today, there's a lot of questions where you're going to have more than one way to do the question. You just, sometimes you just pick the one that makes the most sense to you. Quite often, all 3 of them will work, but not always. So let's just take a look at when you use specific methods. So I like the fundamental counting principle. So I like this one. Setting up the blanks is the best one when we have restrictions on certain spots. So like this question number 2, there was a restriction here, a restriction on the first one. This is a really good question where you have to do fundamental counting principle because it's the only one where you can sort of control what's happening in certain spots. Now, the question that we were doing here, number 5, we had 6 people and we're lining them all up using all of the items. A question like this, my favorite method is factorial notation, just because it's so quick and easy on the calculator. If you're using all of the elements, that's the way to go. Now, the NPR method, again, it's fine here in this situation, but it's kind of more used, I think, more often when you're not using all of the elements. So what if there were 6 people, but we were only going to put 3 people in the lineup? So in a situation like that, I'd have the 6 here and the 3 here. So a sort of typical question for that would be our very first one here, where we had 13 letters available and we're only going to make arrangements of 3. So this is a good one for, we could have done on this one 13, pick 3. So everybody go ahead and give the quiz that we've got posted a try. Do your best. Remember, it is open book, so feel free to look back at old questions that you've done in your notes or in your assignments. Remember to read carefully, and don't forget, short answer questions are just like numerical response. All you're putting in there is numbers. All right, guys, good luck on your quiz today.